Let's take a look at blower motor operation and testing. Once removed, the blower motor assembly can be bench tested with a 12-volt power source if necessary and inspected for damage. The fan assembly or squirrel cage should not have any chips or breakages in the fan. A clicking or ticking sound when the motor is in operation can indicate breakage on the squirrel cage or just dirt and debris packed into the HVAC housing. Sometimes removing the blower motor assembly and cleaning out the area is the only fix that is necessary. As the blower motor ages, the bushings in the electric motor start to wear and can often squeak, especially when under load. At this point, the blower motor assembly needs to be replaced. A blower motor resistor is a device used in series with our blower motor to drop voltage and therefore reduce voltage going to the blower motor. This reduces the fan speed. It does so by having different levels of resistance internal to it and therefore drops different voltage levels. When your fan switch is set to a low speed, it directs the current through the path that has the highest resistance through the blower motor resistor. This also generates the most heat and is often the portion of the resistor that burns out the quickest. The resistors are in the path of the airflow in the HVAC box or plenum assembly to help cool the unit and make it last longer. With an ohm meter and a schematic, you can test the condition of your blower motor resistor. A reading of OL or open in any path indicates a failure in that path or resistor. You can test blower motor resistors either by doing resistance checks or voltage drop testing. The blower motor switch is on the ground side of this circuit. Power comes from the ignition switch through the blower motor, and then the blower motor switch selects which path through the resistor the current flows. Voltage testing at your blower motor resistor can be useful in diagnosis. Because I looked at my schematic, I know that the black with tan wire is my source voltage. So I should have battery voltage at that terminal, which I do. When voltage drop testing at your resistor, find your source voltage and the wire correlating to the selected speed on the dash. The higher the selected speed on the dash, the lower the voltage drop should be present at the resistor. This is the voltage drop across the resistor with the fan in the low speed. Because the resistor is wired in series with the blower motor, voltage drop across the resistor is inversely proportional to blower motor speed. Meaning if the blower motor resistor is dropping 4 volts, there are only 8 volts left for the blower motor. If the resistor is dropping 1 volt, there are 11 volts left for the blower motor, meaning a higher speed. An amperage reading can be taken anywhere in series in the circuit. It is not usually recommended to use your DVOM because the fuse internal is limited to 10 amps. An inductive ammeter such as this is a useful tool when testing blower motor circuits. Low amperage in the circuit could indicate unwanted resistance and therefore cause the blower motor to run at a lower speed than desired. Higher than normal amperage readings can indicate worn bushings in the blower motor unit or obstructions such as dirt and debris in the squirrel cage. Remember, high resistance will cause low amperage and will not cause blown fuses. Mechanical resistance can cause high amperage and can blow fuses, as well as shorts in the circuit. You can also test amperage at your fuse block. By removing the blower motor fuse, and using a fused meter lead and an ammeter, or a fused meter lead and your inductive ammeter. Blower motor amperage draw and voltage drop can also be measured at the blower motor if it's more convenient. This also aids in pinpointing diagnosis. Modern vehicles use the HVAC control module to control blower speed in place of a resistor. This means that certain functional tests and data can be diagnosed using a manufacturer or high-quality scan tool. In this case, I can see my blower potentiometer percent, my blower potentiometer state, which correlates to the percent, and then my blower motor commanded percent as well. I can move my blower switch through all of its positions and check the functionality of each. If there is missing data or dead spots in any of the positions, it is likely that the switch internal to the module, in this case, has failed. If functionality is verified with the scan tool, the integrity of the blower motor circuit must be checked. Many vehicles use a blower speed feedback circuit to report actual blower speed to the HVAC control module. Integrity of this circuit is vital to system operation and needs to be diagnosed similarly to other electrical systems. That's a quick overview of blower motor testing. Any questions, leave in the comments, and don't forget to like and subscribe. Thanks for watching.